So I'm thinking we start here. Does that seem right?
Yes.
Some of my hits for looking at the videos are me because I go back to see where we stopped. Nothing like looking at your own videos. So, okay.
It's not April anymore.
What's that?
I usually put the date at the top, and it's not April anymore.
Not April anymore.
It's April for a long time.
So let's look at this. We're basically dissolving ammonium nitrate. You can tell by the S and the AQ. And one of the things we talked about earlier, what do you think about entropy? Is entropy increasing or decreasing?
Entropy is more chaos.
Mm-hmm.
So entropy is increasing.
Yes, perfect. Very good. You already know the answer to the bottom one there. Okay, so we're going to actually knock out all three. Those are thermodynamic properties. The enthalpy is the H, the entropy is the S, and Gibbs free energy is the G, right? So we're going to come up with all those quantities for this just dissolving ammonium nitrate. You're like, how hard could that be, right? And so I thought let's kind of remind ourselves with regard to enthalpy, if it's endothermic, is that a positive or negative?
If it's endothermic, it's positive.
Yes, very good. I have to concentrate. How about exothermic?
And
Negative. Okay, how about change in entropy? What if it's becoming more ordered?
I'm sorry, what's the question?
Yeah. Oh, delta, what is it positive or negative? If delta S is, yeah, sorry, what is delta S if its system's becoming more ordered? Is it positive or negative? More ordered. Does more ordered favor spontaneity?
I'm sorry?
Does more ordered favors it to be spontaneous?
No.
Right.
So negative.
It is negative. Very good. What about becoming more disordered? Positive. And then do you remember the delta G? If it is spontaneous, will it be positive or negative?
If it's spontaneous, it's going probably to disorder. Right? So,
It's going disorder and getting rid of energy. So
so it'd be positive? No.
because it's a negative T delta S. So actually, yeah, it's negative. It is negative. Yep.
Negative 2.
So delta G is equal to delta H minus T delta S. So if your delta S is positive, like you said, it's going to, the fact that it's negative T times that makes that term negative. So your delta G is negative 2. Yep, you got it. So this is an extra slide just to kind of remind you, yeah. The technique, we could go either way, and in your homework, you're going to want to do either way. But this one, actually, we're going to look at the dissolving of ammonium nitrate, and we're just going to focus on this one down here. So if you look up the, for the solid and for the dissolved ammonium nitrate, you come up with these thermodynamic constants. So it's always products minus reactants. So in this case, it's the aqueous minus the solid. And the stoichiometric coefficients are 1. So actually they end up being pretty straightforward. So stoichiometric coefficients in the process is 1 mole of ammonium nitrate solid goes to form 1 mole of ammonium nitrate dissolved. So we have, again, it's the AQ, it's the aqueous product minus the reactant. So that's where those came up with. If you're like me, what really gets me with these sometimes are my negatives and my minuses. So that's looking endothermic. And then we could do it, the same thing with the entropy. And you told me that it's going to more disorder, so it should be positive, and it is. So of course in this case we're taking 259 and we are subtracting 1.51. Sorry, we're subtracting 151.1. So that is becoming more disordered, which you would expect. Now we're going to just go ahead and use that last column to come up with the Gibbs free energy. So it's the product minus the reactant. So minus 190.6 minus a negative 183.9. So what do you think? Is it spontaneous?
Yes.
Yes, it is spontaneous. Very good. Ding, 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 ding. So yeah, we kind of have some things down here at the bottom. So the fact that it is, the delta H is positive means that it is endothermic. And the fact that the delta S is positive means it's going to more disordered. And we said that this would favor, the entropy favors, and this would disfavor. So the fact that the thing is spontaneous at all, we say that it is driven by the entropy term. So it's spontaneous and it's entropy driven. That makes sense. Because like if one fights against it and it's spontaneous anyway, then the one that supported spontaneity is the driver. So, I wonder who came up with that term, driven. Okay, I can't remember what's next. Oh, an assignment slide. So you might, I know you're kind of getting ready for the final and stuff, so you might want to decide if you want to do these extra credit or not. Okay, yeah. Because, and the reason I picked those three is those three actually will get you, they will be good practice for the material. So I would really strongly consider 23, 24, and 26. So we'll take a look at those right quick. Chapter 19. There you are. All right. So 23 looks like this. We're reacting ammonia with hydrochloric acid to form ammonium chloride. And we've got enthalpies of formation and Gibbs free energy of formation of everything. We're supposed to come up with entropy, delta S. Okay. So this is what I would do. You're like, I don't have a column there for delta S, or S, drat. That would have been easier. So I would come up with my delta H first. Oops, sorry. And then I would come up with my delta G. Come back here. And then I would use that other equation, the sheet I just gave you. It's the fourth equation on the right-hand side. That's what I would use after you have delta H and delta G. There we go. So you get delta H and delta G from the thermodynamic information, and then you have to plug into this. Okay? Now, don't let it throw you off if you're ever missing a temperature and you have the little superscript. That gives you the temperature of 25 degrees Celsius. But don't use 25 degrees Celsius because it has to be in kelvins. So, yeah. So that's that one. And then there's this one. You're going to want to use Appendix D to come up with delta G for all those. And then is this extra credit? Yeah. This one's extra credit. Determine delta G and whether it's spontaneous or not. See, delta S. Oh, okay. So you have to do it a little bit of a roundabout way too. You're going to use the appendix to come up with delta S if you decide to do this. And then once you have delta S, actually delta H RXN was given in the problem. So you can knock that out. And then, is this one for regular credit? Okay, same as 25. And this is this extra credit? 427, yeah.
I think so.
Okay, because this one is a Hess's law. So you see the A, B, and C over there on the right?
Mhm.
Those are your equations of interest, and 1 through 5, those are your puzzle pieces. Oh my gosh. So basically, you need to manipulate and if you like Hess's law problems, they're kind of fun. But you need to manipulate those as puzzle pieces to get those equations of interest. So actually on hints, though, I've kind of told you what you do for A, B, and C. And then, like, if you do manipulate it, then you need to modify your delta G for that prime.
Okay.
Yep. And then remember, and actually this would be good review, I guess, but remember, if you do that for delta H's or whatever, then to add them up, you multiply them together to get the overall delta H of interest, I think. So. And that's it. But that's extra credit.
Okay.
Okay.